Now, how does this happen? One of the keys about virtualization is the dynamic nature of it. Any server anywhere could be running any process at any point in time, depending upon demand. Well, from a facility side of it, I got to supply that power. So how do I supply power to an unknown entity that may or may not require it? And how does the processors move around? Numerous organizations out there, and in my presentation here I'm going to talk about VMware. Arguably, that they pioneered the virtualization concept. And really what they're talking about doing is, if I take an example of a 1 megawatt or 1,000 kilowatt data center, and I look at the rows, and here I've got 10 rows of power. Well, I'm going to take those rows and I'm going to break them up into pod 1, pod 2. Zoned type of approach, and a lot of data centers today are looking at these zones. This zoned approach is not only applicable within one data center. You may have, for example, Google, where data center A is a zone to data center B. So they're multiple zones working in tandem. Now you can accelerate that and you can have 4 or 5 or 6 zones. But the concept is, when my processing requirements drop below 50%, maybe in the middle of the night, maybe in an off-peak season, maybe during the summer. Likewise, the alternative, when Christmas rolls around and in the retail sector, the requirements increase by 200%. So seasonally and by time of use, you make the adjustments. When processing drops to 50%, what happens is a process called vMotion kicks in, I hope. And it starts moving the processors. Move from 50% in pod 1 over to pod 2. So pod 2 is now operating at 100% utilization. Now the key is, and here's the rub, let me turn off power to pod 1. Let me go lights out in pod 1. I don't need to have the electrical infrastructure supporting it because I'm not using it. So now what I've done is I've basically cut my processor, cut my data center in half, using only half of it. Now, power drops down to 25%, I can go one step further and only use 25% of the data center. When power ramps up or utilization ramps up, I can move backwards. This is what the IT world is doing, right? And it's, again, not tied to one data center. Could be the data center in the East Coast, shifting loads to the West Coast because power costs are different at different times of days. Maybe there's a disaster coming in the East, so move it over to the West. So all of these factors are now coming into play